All right, gents, welcome to another statistics asynchronous assignment. We're talking about a few more definitions here that we can use to describe a distribution or a data set. And the first of these is unimodal versus bimodal versus multimodal. Each of these is talking about the number of peaks in a data set. So unimodal has one peak. Bimodal, 2 peaks. And of course, we can just carry on the pattern trimodal, quadmodal, quintmodal. I don't know. After 2, though, we just say multimodal. So 3 or more peaks, right? And we can always tell how many peaks a data set has by looking at either a histogram or a bar graph, right? If we're dealing with categorical data, or a dot plot. Dot plot would work as well. But if we look at this first description here, this guy is unimodal, right? Because there is one peak. Similarly here, there's also one peak there. It's unimodal. So it looks a little strange. Right, that guy on the right, that would be unimodal. We normally think of our peaks being somewhere in the middle. But of course, it doesn't have to be the case, especially for bar graphs, because we can kind of rearrange the bars wherever we want. So this would be both examples of something unimodal. One peak. All right. Over here, this guy bimodal, right? 2 peaks, 2 biggest kind of portions. And this guy over here, we can say is multimodal. Multimodal. Why? Because I see like 1, 2, 3, 4, maybe 4 peaks, something like that. Again, but these are all very much a kind of at the whims of the statistician, right? So while this guy on the left, I would say probably has 3 peaks. Some other people would say 4. Some people might say 2 peaks. And why do I say 2 peaks? Because actually, these 2 charts are of the same data. These 2 charts are of the same data. This goes from 1 to, it looks like about 2.5. And this goes from 3.5, excuse me, 3.5. This goes from 3.5 to 4.5, and so on. It's just transforming this chart into that chart, right? Using smaller intervals. Right, using smaller intervals. Bigger intervals, excuse me. All right. So, excuse me, it's, let me rephrase that. It's not just moving that into that using bigger intervals. This one is talking about the frequency of the length of a first name. So, for instance, first name with length 7 happens 1, 2, 3, 4 times. So length 7 happens 4 times. Length 4 happens 6 times. So where can we see that? 1, 2, 3, 4, 5, 6. Right? So by transforming this chart, by making it look something different, we took a multimodal thing and made it bimodal. So it really depends on how you're displaying your data and what you're talking about with your data. So, but that's unimodal, bimodal, multimodal, right? We think of modal as the number of peaks. Next up, we want to discuss sample versus population. So what we did in class yesterday is we kind of discussed this, right? We said an example is heights at Chaminade. right? We did that yesterday, heights at Chaminade. And we said, like, the population was the 1,700 students, right? And the sample was the, I guess, less than 20 students that were in our class, right? Population versus sample. In statistics, what we use a population for, the population is the group we want to learn about, right? So for example, we wanted to know about the heights of the Chaminade students, so our population was Chaminade students, right? It's kind of what you're studying. The sample is the subset of the population you get YOU get GE info from. So I asked you in class yesterday for your heights. You were my sample. Okay? We want to use information from the sample to make inferences about the entire population. Okay? To use information sample to make inferences about the entire population. And that's really kind of what all of statistics is. That's kind of what all of statistics is. So, what next? Well, let's talk about this in a little further detail. A statistic versus a parameter. Okay? A statistic, this is info gained from a sample. Right? For instance, the sample mean, which was X bar. Sample variance, which was SX squared. Sample STDEV, standard deviation, which is SX, right? We can calculate this about the sample. Versus a parameter, this is an assumed value of entire population we are testing. Quite often we're testing. We're not always testing, but it's normally the thing we're trying to learn about. So for instance, today we were trying to learn about the average height of the Chaminade student by examining the sample of your heights, right? We don't always know the population parameters, but we often have estimates of them or things we want to check about them. And we have different notation for it. So like a population mean, we use the Greek letter mu. Mu. All right, the population mean mu. We have the population variance. Which is the Greek letter sigma, lowercase sigma in this case. Sigma. Then we have the population, lowercase sigma squared, excuse me. And then we have the population standard deviation, which is just sigma. Right? So we use different variables, we use different letters to stand in for samples versus populations. Okay? Next, we have the mean versus the median. These are both measures of center, right? Measures of center. They both are measures of center, measures of central tendency. They kind of give us an idea of what the middle of the data might look like. But they have their pros and cons. If the data has no outliers, the mean tends to be better. Or if the data set is fairly large with limited outliers, the mean is better. If this data set is small, the median is a better description of center. And what do I mean by that? So let's just take a look at a quick example. 1, 2, and 3, right? In both cases, the mean and the median is 2. The mean and the median is 2. All right? There's no real outliers here. The mean and the median is 2. What if though I replace 3 with 300? Well, and that's maybe, the example is maybe a little small. If I did 1, 1, 2, 2, 2, 3, 3. And I kind of want to know what is most people doing in here. Again, the median and the mean are both 2. And that could tell us like most people are kind of close to 2, right? But what if I make this 300, right? Well, the median stays at 2, but the mean blows up. The mean is what? 3, 4, 5, 11, 311 divided by 1, 2, 3, 4, 5, 6, 7. 311 divided by 7, so it's over 40. Right, the median is over 40. The median's like 44 and change. The mean is like 44. So the mean is sensitive to outliers. Right, the mean is sensitive to outliers, where the median, we say, is resilient against outliers. Right? So if you're running a statistical study, you want to use the mean if you don't have any outliers, and the median if you do. Because the median will give you a better description if you have some crazy outliers. Right? Both are useful. And you get happy when we do the median because like it's easier to calculate. Then we have standard deviation versus interquartile range. These are both measures of variation. Right? The standard deviation you use with mean. Right? So when you take the average, when you use it with the mean, you use the standard deviation. And the variation, the interquartile range, you use with median as a measure of variation. So anytime you use the median to describe your center, you want to use the interquartile range as a description of your variation. Why is this? Well, if you remember from the calculation of the standard deviation, we use the mean a lot. And if you remember from our calculation of the interquartile range, it's just the median of the median. So they are very much related to whatever measures of central tendency that we're using. And finally, one thing for today, we have box plots, also known sometimes as box and whisker plots. And since they're box and whisker plots, I figured I'd throw my dog on here. She's got whiskers, right? Let's stop drawing all over my dog. For those of you who don't have me, her name is Nilla, who didn't have me last year. I claim it's short for Vanellope. My wife refutes that strongly. But I do claim her middle name is Helen Mirren, and not so many people complain about that. So that's Nilla for the box and whisker plots. All right. What we're going to do is we're going to calculate a box and whisker plot for this Apple sample. This is a sample of ratings of an Apple and a Samsung tablet. Okay. So first thing first, if we're making a box plot or a box and whisker plot, one is we look for outliers. Right, and outliers are a little tricky. It's not always obvious when we have one, but I would say maybe 73 is an outlier. I would say 73 is an outlier. Okay, and so we can disregard it. Right, we'll include it later. Look for outliers, disregard it. If we're making a box plot is a description of involving median. So we're going to calculate median of remaining. Right, after we get rid of the outlier, calculate the median of the remaining. So if we want to do that, we can do our cross out thing, but it turns out like 84 is our median. These are already in order. I can cross out everything down at the bottom and everything down at the top, and that gives us our median. Calculate the median of the remaining. All right. Step 3, calculate the lower quartile and the upper quartile. And again, remember that's the median of the medians, so I just need to take the median of that and the median of that. So it's 86. And then if we do the same, we're going to get 83. All right, so our upper quartile is 86, our lower quartile is 83. Okay. We also need the min and max, so 4 min and max without outliers. All right, so we disregard the outliers. We have our min is 76, our max is 87. Okay? And then we can draw as follows. We start on the bottom with a key, right? And what do we put on it? First off, I make it a little straighter. Right, we start with a key on the bottom. So this is Apple satisfaction. That's one way we can put it, Apple satisfaction. We label our graph. And what do we plot? Well, first thing I will plot is our min and our max that we care about. So we have 76. We have 87. And above them, they get little dashes. Okay. Now next is we put the lower and the upper quartile. 83. 86. Now I should probably move 83 over because we're trying to draw this to scale. All right. We throw the median on there. So it's like over here somewhere, 84. And then finally, we do the outlier, which we can do, so here 73. And we can think of it as like maybe we draw a little star or a little point or something. It's just something we include on the graph, but it's not part of our box and whisker plot. And then finally, to make the box and whisker plot, we're going to make a box using my upper and lower quartiles. I'm going to plot my median. So there's my box, and then here are my whiskers out to the max and the min. All right, there's my box and whisker plot, and it tells us kind of how data is bunched. This is saying a lot of the data is between 83 and 86 based on median, right? So most of the data is in this green box. All right, what this doesn't tell us is about peaks. This doesn't tell us about peaks, and that's okay, right? We use different ways to talk about data, different ways of displaying data to show different things. So here's a box and whisker plot. Your first problem for homework is going to be doing the same for the Samsung tablet. Okay, all right, you notice there probably is an outlier as well. We can already see that, but this will be the first problem for your async assignment, excuse me. So 4 problems. 2 and 3, maybe you have to do a little writing, that's okay. Same thing, 4, you got to draw a histogram. For these standard deviations, remember we can draw a picture which will have different standard deviations. We can tell whether it has a bigger or a smaller standard deviation based on the picture. We don't actually need the numbers, so I want you to kind of think about that and see what you think about how to do that. And question 5, if you get all these done, you get a little DAP from Nilla. So nil DAP is always good DAP. Have a good day, gentlemen.